Okay, on this episode of Broken Lemax Stuff, we have a boat. As you can tell, it's kind of in pieces. It's no longer attached to the base, and more pieces will fall off. This was dropped, and unfortunately, it didn't do so well. Apparently, it's the river Belle. And we're going to see if it's salvageable, repairable, what have you. I have no clue where any of this goes, what it did. I'm assuming, well, it definitely made sound. I have a gearbox here, and it looks like there's supposed to be a belt on it, because there's a pulley. I'm going to assume the pulley was attached to this wheel because there's a similar piece of plastic with a groove, and there's also a hole right there. So I'm going to assume that it just sat in one spot on this platform. The platform lit up because I have wires that go inside the platform that are not the white ones from the power. And I'm sure the platform pulsated or just stayed solid. And we had lights up here that were on, which are right here on the top. I don't even know if this is the whole ship. There might be other pieces missing, like this front walkway on the bow. There's a piece of the railing missing. And the rope is broke right here, which is probably attached to the other side for the gangplank. So, the first thing I'm going to do is, also the battery cover is missing, and it rattles, so I don't know if something inside here is broke when it made its trip to the ground. And this wheel spins continuously. It gets tight and then it spins again, so there's probably some damage in here. I want to put power to it and see if the speaker works, and maybe if we get a couple of lights inside the hard plastic base. But first, let's open this and see if the switch took any damage on its journey to the ground. This one actually has a circuit board inside. That's pretty rare. Normally they have just a switch with some wires, maybe a resistor. Oh, I know why. It's a 4.5 volt power supply, but if you notice this braided wire, there's more than just two. If it was just 4.5 volts, you'd have two wires, hot and negative or ground. It has multiple wires. There are 5 white wires. So, and these 5 white wires come in, which actually change colors because they're painted wires. As white as paint, because they're red, blue, green, and black, and kind of a peachish tan, which when it comes out of this loom right here, it changes into the blue, red, peach, and black wires. So it's probably taking the 4.5 volts with this little circuit board and maybe making something 1.5 volts, 3 volts, 4 volts, 4.5 volts, 2 volts. So it's a multiple power supply. So this circuit board has multiple powers. Also, we have a broken or non-connected resistor lead here. So I don't know if any of this is going to work or if it's even salvageable. If it's not, it'll be parts for future Lemax items. So first things first, I have a 4.5 volt Lemax adapter plugged in. And let's see if it turns on the smoke or if it does anything. Nada. No lights, no heat, no sound. Actually, the sound would be pretty hard since apparently those sound wires are broke off. But this motor, I think, would have spun. It's the only thing that seems to be attached to the circuit board. This motor and the lights on the base are the only thing still hooked up to the circuit board. The LEDs are separated, the speaker wires are separated, and then the lights that go up in here are separated. Alright, what about the trusty meter? Set it for DC. And what I'm going to do here first is, power supply should be good, but let's double check it. Actually, let's just double check it this way. 4.64 volts. So we're getting good power from that. And let's check the incoming power. Alright, need to tip this up so I can see it. I don't know if you'll still be able to read the numbers or not. We got a red wire here, which I'm going to assume is one of the hots because it comes out of the bundle, and a black wire. We got 0 volts. Let's go red to blue. 0 volts. Ah, there's the black wire that returns to the power. So. Nothing. 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 Here's the white wire. Nothing. Yeah, I'm not getting anything coming through. So this is probably broken in here from the impact. It probably fell on the back of this. So, how can we get this little circuit board out? The plastic staked it. That's what this is. These two white spots right here, and this white spot right here that's smeared. It kind of looks like grease. It's actually the plastic that's been heated and then folded over the circuit board. So, I'm going to try and bend this one out of the way enough to get the board to come up. I'm going to need another screwdriver. These plastic stakes I'm just going to have to break off, like so. Little sticker with some, looks like Chinese symbols on an arrow. Not a clue what that's from or for. Apparently this style circuit board's kind of hard to get out. They really put it in there. Got it. Alright. Let's try it again. Probably the stupidest thing. Got no power at the motor still, and no lights. Oh, they flashed. There we go. yeah, there is some damage on this little circuit board. Yeah, this motor is turning really slow. It's having a heck of a time. I'm wondering if one of the gears in this little clear gearbox is broke. The amber lights are all working, unless there's supposed to be some here which aren't. Very possible it's not, because this would be the back side of your display. Usually where the power wires go in, you don't have facing forward. Or it's possible it's just supposed to turn this slow. Now let's do some voltage checks again. Apparently I didn't flip the on-off switch all the way. We all make mistakes. So from red to black, I'm getting 2 volts. And from brown to black, I'm getting half a volt. From white to black, I'm getting a half a volt. Blue to black, I'm getting nothing. And that's it. So, it might be somewhat salvageable. There's no drive belt, probably broke. I'm assuming it spins that slow. Don't know. Now we need to figure out the rest of the wires. Yeah, that switch is going out. So, let's see about unscrewing this circuit board. Looks like there's a lot of hot glue and resin and stuff in here. So we have the blob chip, which is standard for proprietary purposes, so people can't copy what is in here. We have a standard IC chip, probably a timing chip. We have another resistor that's not attached to anything. It says M+, which usually M means motor in electronics. And the other side says M-, which is connected to the blue and red wire coming out of this box on the other side of the board. That's if it passes through. It might be a 2-sided board. Doesn't appear to be. And this motor is attached to the white and black over here. That's not labeled. There's no marking for it. But it is on the same rail. I'm wondering if this had another motor. Probably not. There's nothing else for it to do. I don't think it's one of those ones that rock, because there's no piece of plastic for it to ride on. Turn off the meter. So we got a random resistor here sticking up and a random resistor here sticking up, which I'm going to assume is some of these wires, because I bet you it's for the lights so they don't get burned out. What I'm doing is I'm looking at the board, trying to read the different symbols to try and figure out where these 2 wires go. These 2 wires go. These 2 wires go. These 2 wires and these 2 wires. they're all black except for the speaker, which is red, and then these wires here that go to the front of the boat, which might be a motor. It's hard to see inside. I don't know what the motor would be for, truthfully. They're yellow and black. You see this place right here with the resin. That's the place where the yellow and black wires go. Might break it out just to see if it'll pop out, if the resin's just brown enough to crack. Nah, but the porcelain is. So we're not going to do that anymore because I just chipped it. So I know everything on this unit runs at 4.5 volts or less. So I'm going to turn on a power supply that can put out variable voltage. And I'm going to start at 1.5 volts, which would be equivalent of 1 AA. What I'm going to do is we're going to send power to the top of the boat and see if we can find what's negative based on the amperage reading and if anything lights up. So I'm getting no excitation, so we're going to crank this thing up to 3 volts, which would be the equivalent of 2 of the batteries. And there we go. So, these 2 black wires are these lights here. Which apparently some of them are either burned out or they're flickers. No, they're flickers. I'm now at 4.5 volts. It's pulling just under an amp. And that is these lights here. So I'm going to drop it down to 3 volts again as a safe voltage. Let me see if I have some tape. I do. What I'm going to do with the tape is mark the wires. So all these yellow rope lights. Power. The reason I'm going to mark them in advance is I don't know how many days this will take to repair, depending on what's wrong with it. I should have marked which is hot and which is negative. It's fine before I solder it to the board. I will test them again. Now let's see what this yellow and black wire does. If it's a light or a motor, it'll turn on. If it's another speaker, it's going to make a static sound. So I'm going to assume black is negative and that yellow is positive. And I don't see or hear anything. That's at 1.5 volts, so I'm going to crank it up to 3 again. The needle is barely starting to move on amperage draw, so I'm going to crank it up to 4.5. Nothing. So I'm going to turn the polarity around just in case. And I'm getting nothing. So I don't know what's in there. When I touch it, it's bouncing between 0 and 0.05 amps at 4.4 volts. Let's turn it back down. So I'm probably going to have to heat this section up and separate it so I can see what it is. With my luck, it's probably a speaker, and I don't know. I'd have to look up the Belle boat to find out. I can't see through the windows to see what it is. All I see is a shadow. I would assume it would be a pulsating light, make the inside glow. But, don't know. Never owned this boat. Alright. I've got a brown and black wire that comes off the circuit board. I have no idea where that goes. I don't know if the brown and black wire was connected to the yellow and black wire, if it was connected to these two black wires, or if there's something else that's supposed to light up or do something on here that is missing. Either broke off, fell off, ripped off. I don't think the captain's facing the right way. See, even nope, he's not attached. That's why. Like usually the steering wheel's in the front of the ship, not facing the back. So let's see if we can find sound. At least they're nice and told you the values of the components on here, like a 220k resistor, a 680 ohm resistor, a 510 ohm resistor. It's actually printed on the board. It's pretty rare. 27,000 resistor, ohm resistor. Capacitor is 103 on the ceramic. And then the other ones are printed on the sides. What I'm trying to find is the symbol, or if they have one, for the speaker, which looks to be right there. So it looks like the speaker is behind the, or in front of the chip technically, because it has a square with a triangle, which in some places they've done that as a speaker. I know it's not a diode, that symbol's over here. So what I can do is just touch the speaker carefully when I give it power. And let's just trace the tracks real quick. One track goes to, well, they both go to the chip. So there's a good chance this is correct. Oh, there's the speaker. Try and get this closer. I'm going to do what I can to make life easy in case you ever have one that falls and shatters into a zillion pieces. If you see the black chip, and you see this right here, this white symbol printed on the board, which is a rectangle with, in this case, it's an offset triangle. It usually is the symbol for a speaker. There are other symbols I've seen, but that's the most common. So we know that's the speaker. Get the soldering station fired up so we can solder at least these wires back on. There's some of the glue. The boat kind of reminds me of Ghost Ship. While the soldering iron's firing up. If you ever seen Ghost Ship? In the beginning of the movie, there's a boat where the main cable gets snapped. That goes across the top of the ship. And it decapitates everybody on board except for one little girl. All the characters are missing their heads, except for one little girl. So, it's kind of ironic, I guess, or coincidental. Let's get that out of here. I'm gonna have to, if this is salvageable, it's all gonna get re-adhered with better glue. But yeah, it's very ironic that the boat has the same destruction as the movie Ghost Ship. So, alright, soldering iron's up to temperature. So let's solder on the speaker wires. Untangle them somewhat so they're not in the way if I can reassemble this boat. This boat will never be back to its original glory. I don't have the missing heads, and I don't have any of the other missing parts that the boat may have had, or the broken pieces that are missing again. Nice and warm. I'm going to tin the wires so we get good connection. And this solder looks horrible on the board, probably because of its age and the type of solder. China, a lot of the Chinese solder is lead free, and I'm going to touch up the pads. There's a lot of flux in their solder. Alright, what I'm actually going to do is just suck their solder off and put all fresh on. This is a solder sucker. What you do is you get the pad hot and then press the button once I charge it, and it sucks the solder off. There's a solder wicks, and there's different types of units that do this, but I use this one. There we go. What that does is it gives me a clean surface to solder back onto with fresh solder. Two. Alright, let's give it power. Wiggle this around, however I did it before. Got a bad switch. I gotta hold the switch because the switch is bad. Let's turn the volume down. Okay. So, now let's see if we can find where the lights go. Still thinking this is for the motor, and I think that's another motor in here. What I do is turn on my power voltage meter again, and I want to check the power coming off this resistor as best I can. touch the resistor, and I'm going to touch the negative. And I'm getting, it's fluctuating between 3 volts. I'm getting 3 volts out of this resistor. So, if this is technically a motor, then something should technically happen at 3 volts. So we're going to touch that one there. And I'm not getting anything on the negative. We also have the 2 wires here for the LED. Not sure where they go. And I'm not sure what power it consumes. Depending on the color will depend on its actual power consumption. One wire is gray, one wire is black. I'm going to set my voltage to 1.5 volts, which is for like a red LED, that's at the low end. I'm going to do gray for positive, black for negative, and I have nothing. So let's bump it up slowly. Nope, went up to 2.5 volts, nothing happened, so we're going to reverse the polarity. There we go. So at 2 volts is starting to come on. I don't know if you can see it. I'm at 3 volts, 4.5 volts. It's on solid amber. I'm hoping you can see that. Trying to shield it from the outside lighting here. So black is actually hot and gray is negative. Now, I don't know if it's supposed to flash, if it's supposed to pulsate, if it's supposed to only come on when somebody's talking, or if it's just supposed to be on. If it's supposed to be on, it should just be soldered directly to the incoming power. But then again, I do have this other resistor on the bottom of the board that is connected to the same motor rail that's on the positive side of the rail right here. Since we got power going in, let's check what this one is. This is 2.7 volts, give or take a 100th of a volt. So 2.7 and 3 on opposite sides of the board. They're the same power, brown, black, black. This one is black, silver, brown. No, those are different resistances. What I'm going to do is, there's pads that have nothing soldered to them, probably the broken wires, and I want to check any of the voltages coming out of the pads and reference the ground. So this outer edge of the barrel is ground, so I have my negative lead there. And this pad says I'm getting 0.3 volts. This pad is the same. This pad is 0.4 volts. This one is 0.4 as well. What I'm trying to do is find where these lighting wires may have been. Solder joints all look the same. But I'm going to put on a magnifying glass just to get a better look. This looks like a broken wire right here. 1.44, 1.5 volts, round figures. This one next to it is 3 volts. The one next to that is 1.44 volts again. This one looks like a broken pad. Yeah, that one should be 0 because that's supposed to be the ground rail. With a magnifying glass on, I can see the solder joints better, and I can see that some of them appear to have possibly had stuff stuck to them in the past. There's 3 solder pads right in here that look like at one point they had something attached to them. But I'm thinking it's just the bottom of the, yeah, it's the bottom of the chip. What about that pad? That pad, this pad right here, looks like it may have had something attached to it. It's very possible it's bouncing between 1.5 and 2 volts. That could be a pulsating light. These resistors are really confusing me. They're sticking out of nothing. I wonder if there's another piece of this boat missing. I'd really like to know what these go to. Is there any power on them? No. Not across them. Let's do a reference to ground. Nope. Let's check this one. We have a 1/2 volt. 1/2 volt on the black and nothing on the gray. Grayish brown. I think it's actually brown, the lighting. Yeah. Nothing in reference to ground. In reference to hot, I'm getting 0.8 volts. So this might be a ground, a return. The wires are really chewed up. What I'm going to have to do is try and find a video online of one of these actually functioning so I can get a basic idea of what it's supposed to do. So I'm going to go do that. I'm going to find the River Belle or whatever it was called. Yeah, River Belle. See if I can find a video of it and see exactly what it's supposed to do other than the noise, which figure that one out. To see if this is supposed to pulsate, if it's supposed to be attached to a pulsating light, or if it's just on constantly, which means I can just attach it to the incoming power rails. Also to find out what is this in the front part of the boat that has the yellow and black wire, and then try and figure out what this does. And maybe from there I can deduce where on the board these are supposed to go. Also, I'd like to see how fast this wheel spins. I'm sure it's just really slow like this. It's a paddle boat, not like a speedboat where the thing would be screaming around. So, but then we got to figure out how to repair this box since it's damaged. And then, of course, just glue all the pieces back on if it's completely repaired. Like I said, I don't even think all the pieces are here. I'm not sure. But anyhow, I'll return with some information once I find hopefully a video on YouTube or even on the Lemax's page of this Belle boat and figure out exactly what it's supposed to look like when it's complete. So I'll return. Alright, I was doing some research online and I found a video of it from a YouTuber named Mad Scientist who posted a short video of it working, probably for a listing to sell it, since in the comments it said thanks for your interest in this item. What I did do is I started the heat gun up and I just heated this piece up to break the resin free. I just turned it off so you didn't have to hear the sounds on the camera. And now I'm trying to pull it out. One, it's a little warm. Two, it's a really tight. Oh, they're just lights. They're just lights for the walkway. As you can see, the stairs. So, and they're resisted. There's a resistor on each one. And one's a standard LED, one's a oval or flat LED. And this one has a black wire and a sheared off wire, which I'm going to assume is probably these black and gray wire here. The black wire was probably right there, and the gray wire was probably soldered right here. And so it probably was attached to two different sides of the circuit board. So the piece I chipped was part of the bottom of the stairs. So let's turn this bad boy back on and start out low voltage again. I'm going to go 2 volts. And let's find out, one, the colors. I'm assuming they're going to be orange. And two, yeah, they're orange. So that's 2 volts. I don't know if you can see it. It's on. That's 2.1 volts. It's 2.4 volts. So this thing cannot run at a high voltage. If I were to crank it to 4 volts, 4.5 volts, it would pop the LED. And the yellow wire and the black wire. So the black wire is negative. The yellow wire is positive. Just going to clip it onto the resistor. This is a very low glow at 2 volts. That's 3. Here we go. So 4.5 volts. That one turns on. So I'm thinking one of the pieces of the board that pulsates a low voltage is to make this one flicker, the smaller LED. And the bigger LED is just to illuminate the stairway. The flicker might make it look like shadows or walking or something, I'm not sure. So, no motor, just lights. So the only motor this has is the motor that drives the big wheel in the back, which is loud. Even in Mad Scientist's video, it's a loud motor. So I just need to figure out where these were soldered on the board. I'll check the voltage on these again and see if it's the correct voltage for this little fella, so we don't burn it out. Because it's either going to be these 2 wires. Well, it has to be. These 2 wires, I got to figure out where they go. This thing runs at almost full power, and these run at full power with the resistor. juice. And in his video, it does look like there's a light here. So it's probably broke. Probably got crushed or the wire broke off on impact. For being a porcelain boat, it took it pretty well. You would think this whole body would have shattered, especially things like this where they're nice and thin. But it's all how things fall. So let's test the theory. These wires are severely damaged. There's cuts in them all the way down, probably from tangling and bouncing. So I'm probably going to end up cutting them off and sticking on a new set. But I'm going to touch the cut black wire. Right there. Then we cut gray wire. Yep, lights up for a second. I'm trying to hold these things. Yep, it's flickering. I'm sorry I can't get you a good shot of it because of the way I'm holding it. So, what do I got for wire? I'm gonna have to use a thicker piece of wire than what they used. I don't have the hair strand type wire. It's just too thin to work with. So I'm going to use a slightly thicker LED wire. That's what this is usually used or referred to as. It's blue and red. We'll use the red for the hot and the blue for the not. Just turn on the soldering iron again. Because this sits up inside, I'm going to have to solder it and then make sure that I can fish it through on the other side of this. Since if I can, I'm going to glue that broken piece on because I'll need access for the wires to come around. That's probably why they tore off the way they did, is the impact. The wires were on the other side of this porcelain bar, and because the edge is relatively sharp, it acts as a shear and there's your wires. Some solder. I'm gonna tin the resistor. Tin the other lead. And get the broken piece of wire off. There we go. Now, this isn't a piece I would normally have, and I probably myself wouldn't keep it, but it's a good learning exercise in how to deduce where things go if for some reason you happen to acquire a broken piece or break your own and you want to try and salvage it. You could turn this into a, your own spooky town boat with the decapitated people and the broke down appearance. You can make it look like a derelict ship, like in the movie Ghost Ship, just floating around at sea. That's what I should have done. I wasn't thinking about it, but the resistor sticks up higher, so if I solder the two wires, it's going to put a kink in the hot wire. Normally what I would do is I would cut the red wire shorter to compensate for the height of the resistor. I should have done that to begin with. So we'll do it again real quick. Just cut off the extra piece of wire that was sticking out until I stripped it back too far. So, the wires are soldered on. Now I'm going to feed them around the bottom of the boat. Like so, as you can see. It's going to make life slightly more difficult. I'm going to also feed the black and yellow wire back around so I can just stick this all the way in. And then when I have a chance, I can glue it back down. I can either use hot glue, which just seems to be the norm, or I can use acetate glue such as Super or Gorilla, which is faster. Or I can reheat the resin and see if the resin will readhere, since I didn't scrape it off. Back into its slot, like so. Alright. So where do these wires go? The brown wire shares the same solder pad as the black wire from the motor. That's weird. Maybe that's why it flickers. It's picking up the noise from the motor. And the black wire shares the white wire to the motor. So yeah, it's kind of odd. Motors are noisy. But that may be how they made the flicker appearance, is just the noise of the motor. Instead of putting in a chip or a circuit to give it a flicker, or even a flicker bulb, they just use the noise of the motor. Whatever works. So, I cut these two wires off. Carefully, like so. And I'm going to put some fresh solder on these pads. Get the smoke out of my face. And get that. Also had to remove the small piece of wire that was left over from me cutting it. And we're going to use a couple of tweezers here. I'm using ceramic tweezers. That way the solder doesn't stick to the tweezers. Also, it doesn't generate heat up the side of the tweezer. So the tips are ceramic. Problem I'm having is you gotta get the old, there we go, the old wire off when I cut. Apparently I didn't get it all off. There we go. Now I can solder that. Retin it. Oops. I figured that might happen. Desoldered the motor. There you go. First coat of solder. I should have made these wires a hair longer. Because of their thickness, they're kind of posing a problem of flexing. Come on. It's probably hard for you all to watch, seeing me do the same thing 100 times trying to get it to work. Trust me, it's hard for me too. Does not want to stick. So. What I do is put a little flux on it. Used it a couple of times. I don't use it very often unless I need it. And the stuff I use is corrosive self-etching. So it reduces the life of the tips on the soldering iron. So it comes in handy. Just doesn't smell good. All right. Let's see if this worked. Can always skip past this if it's boring. All right, positive's on. And the negative's on. Could have saved a lot of time if we just did that to begin with. Hey, the light's on. And it's walking because of the motor. Let's see if I can show you. See the light, maybe right there. You can also see the other wires because they fell back inside. That one. And that one. Alright, so apparently the smaller LED, according to tracing the wires back, these little thin guys over here, they're actually connected to the same power wires as this motor. And if you forget which is hot and which is not, on the back side of this board has M minus, M plus. M minus, negative, plus, positive. Not rocket scientists. At least they labeled it. Makes life slightly easier for people. So now we're stuck with this light and this light. We got two resistors, which I'm assuming are going to be the hots for these two lights. One's going to go to one, one's going to go to the other. And you need to see the difference in voltage between the two is 0.3 volts. I don't think it makes much of a difference as far as how the voltage goes. Both these lights can handle more than 3 volts. This one can handle 4, and this one over here can handle 4.5 with the resistor. But I don't know which one goes where. Plus we also have this string. So zoom into my project and I'm going to give it a little bit more light. Like that. Alright, this black wire here, which goes to the box, has a glob and a broken wire sticking out. So, one of these 3 light sets was soldered here. Technically all of them could have been. This pad right here that says is also on the negative rail, right next to this big resistor, also has wire. Because this outer rail right here is negative. And then this inner rail is also negative. So these 2 rails are both negative rails. So the positives, we got 1 resistor, 2 resistor, which again this one says motor, which is still confusing me why they'd want to hook it up to a motor. I'm not sure where the 3rd wire went unless it was just soldered to the same hot as the motor, this guy, like the ones in here, or if it was soldered to the positive rail on this side. might have been connected to the letter A. I have an A right here which has a wire, but it doesn't appear the pad that's next to it has nothing on it. I wonder if that's what broke off. Again, it's hard to tell because you can't get schematics of their circuit boards. We can just assume and deduce. So these lights, I think we ran at 3 volts. So we're going to have to definitely hook it up to a resistor. So it's going to be one of those 2 resistors. That way we don't fry the light bulbs or the LEDs. It's 2, 3, yeah, so 3 volts. Start going above 3 volts, they start getting really deep and dimmer. That means you're starting to burn them out. You're overdriving them. An incandescent light bulb, an example, the more power you give it, the brighter it gets till it explodes. LEDs actually get dim, and then they start to smoke, and they turn black, and that's the end of it. Sometimes if it's a fast voltage, they just pop. You see a flash, and then they're black. So turn my tape off. This one should have been the positive. Probably helps if it stays clipped. Thank you. Yeah. So that's the positive. So I'm going to tin the positive first, which is the one I just bent up. And now I'm going to tin the negative. And turn it on one more time and see which one of these resistors had the lower voltage and which one had the higher voltage. 3 volts. Okay, the one right here is the lower one. It's at 2.7 and it fluctuates 3 volts, 2.7, probably to make it flickery. So I am going to solder this one to this resistor here. Again, I don't know if it's right. We're just going to do deduction. So I can see the lights. Did that stupid mistake again where I forgot to mark it. Yep. My recommendation is marking them. Don't follow my inability to do things like that. It's also generally not recommended you solder things while it's running. But they're LED lights. There you go. No. Tweezers. Where I put them? Oh, they're right there. Grab another set. Because stop moving. Doing is I'm re-wetting the soldering iron, not getting good heat transfer, and also my lead is too long, touching the other side. That's why everything flickered. There we go. So, try and kill a light here. And that one here. So you can see, and most of these are on. I don't think dropping them helped them any. Some of them are really dim. So they got busted up pretty good. Alright. Now, let's try this one. Let's see if we stick that there. To me, that's just too dim. Where's that last light? Right there. You hear clicking, that's the bright light I flip on that's next to the camera. It's cooling down. I know sometimes the editor gets annoyed with the clicking. It is what it is. Can't do nothing about it. I don't feel like moving the light every time I turn it on and off. Turn this around so I can see the stairwell. Make sure that the light actually comes on like it's supposed to. Yep. So let's this. And resolder the small piece. And both lights are on inside the stairwell. So last but not least is this guy, which is the light right here. And I'm going to double check its maximum voltage. So I'm going to determine where on the board we're going to stick it. So remember right, gray is ground. Yep. And red goes, or the hot goes to the black. So that's 3 volts, if you can see it. And that's 4.5. So we're just going to solder to the incoming power. So tin the wires again. Anytime you solder, it's always a good idea to pre-tin your wires if you're not twisting multiple ones together. That way you get good connection. You don't have to try and carry the solder over to your project. And I'm going to bring over the voltmeter. What I'm going to do is I'm going to check the different points on the board to find what points have maximum power. It's 3 volts. That's 2 volts. 3 volts. 2, 3. 1. It's 3. Where's this wire right here? 3. 3. 3. I was hoping to find max power being 4.5 volts, but it looks like everything coming in is 3. 3 volts for everything. So that means the circuit board over here must resist power going into the unit. Maybe it's supposed to have a dim glow. So, let's attach it to 3 volts. Cut off the excess long leads so they don't arc. Shoot, the white wire broke off. It broke off the motor. Not terribly happy with how bright that is, but it's at 3 volts, which is everything on the circuit board. So the white wire for the motor came free. These wires are very flimsy. They're just, like I said, they're like hairs. So you figure if you're not moving it around, they work perfect, but fortunately, do move it around, even if you're not just packing it and unpacking it, moving it around, you can break them. Go. Cut the excess off. So now it's all together as far as the power part goes. Now we need to reassemble the boat, which I know that goes there, and I know the stacks go here because I saw the picture online. That's how I know these things. See that one. That stack goes there. That stack goes here. sign goes between them. Like so. Still gotta find a drive belt and get it put on. But I got all the lights. Let's kill the get the chair out of the way. Let's kill the main light. This way you can see the overpowering base, the little lights here on the side. You can see the light on top of the speaker. And the stairwell lights. So, probably going to end up using an old band from a cassette player, or a thin rubber band to drive the wheel. I'm not sure what band it takes. I can tell you how to take the wheel off to fix the band. Turn on the light. You have to unscrew these screws here and those screws there. These I'd probably just loosen, truthfully. Take these out, pull this out, slide the band on, or tip it up, slide the band on, and put the screws back in. And then on this side, you have two screws as well. Take them out, slide the band over. Before I do that though, I'm going to re-adhere all the components on the inside so the stair quit's falling out. Try and reattach the chip wherever the heck it shot off to. Part of it's right here. Oh, and I think I said the cover was missing. The cover was actually in the pile of parts, so it does have the cover. But this is what happens when you drop one. So, don't drop one. So I'm going to work on this, getting the pieces glued in and hardened. I'm probably going to use acetate glue for the stairwell. And then I'll probably use super glue for everything else. That way it's still accessible when eventually it breaks again. Anything animatronic breaks. So, and then we'll glue on all the little pieces, figure out where it all goes. I think that goes in there. There's the bell. So, anyhow, we'll return when it's reassembled, at least most of it. We'll go from there. Alright, the boat is back together. Here's a low light shot. Here's a brighter shot. Paddle is spinning. I put a black drive belt, I don't know if you can see it in there. Let's do that. From a old Walkman, or Discman, one of the Sony from the like 90s. Had one lying around, took it apart. Here it is in low light. Base is nice and bright. The walkway's on like it's supposed to. And we got the little lights on the top. Some of the LEDs are broke, so they don't light up. There's that one and that one. And some of these are really dim. But all the components or pieces are glued back on. Some of the railing, the flag, the benches, the stacks. Here's the sign on the two stacks, the bell. The ship's reattached to the base. So this is about as good as it's going to get, with the fact that it's still missing some pieces from the impact, like their heads, a couple of the mooring attachments that go in the sides, the corner piece of the walkway or gangplank. So yeah, for being dropped and not shattering the base, this part or this part, it's in pretty good, well, working order. So here it is all together, done, functional. All the lights, except for the ones that are broke off or smashed, work. Volume works. just like it's supposed to. I just have it turned down. There's the volume knob. There it is. It's not staticky. It's not crackly. So I think we were able to salvage it. Now I don't know if I'm going to keep it or if I'm going to use it for future parts. Or if I'm going to turn it into a... there we go. Turned the wheel the wrong way. Or if I'm going to turn it into a zombified ship, since, again, we got some heads missing. Some heads when I'm rolling. So, well, I hope you enjoyed the video on how to hopefully do some testing and probing to make something work if it's severely damaged. Whether you bought it, acquired it, or did it, meaning you dropped it or something bad happened, on how to hopefully reassemble your piece to make it functional again, whether it be at full function or part function. As long as it looks good to you and it works in your display, that's all that counts. Until next time, thanks for watching.